When SQL injection succeeds, it means that the attacker successfully tricks SQL Server, or any other relational database, into executing an unintended query using untrusted data. This is the crux of any kind of injection attack. Another way of saying this is that the application doesn't keep the command channel completely separate from the data channel. So let's take a look at how this works. I'll go ahead and run the application to show you what the normal page does. Okay, I'll click on this link right here. As you can see, I have a URL that's home SQL injection, so that's the action method in the view, and I want to take a look at the information about customer ID ALF key. And obviously this is hitting the Northwind database. Customer IDs are strings there. And what it does is it returns the customer's name and the number of orders. So very simple kind of a page. But unfortunately, a page that is vulnerable to SQL injection. So let's take a look at the code before we take a look at a way of taking advantage of it. Okay, so this is a little bit strange of a action method. I'm not using any ORM like Entity Framework. I'm hitting the database directly. And on top of that, I'm using dynamic SQL. Okay, I'm getting in a customer ID as a parameter to the SQL injection action method. I'm grabbing connection string from the web.config file, newing up a connection and opening it. And then I'm using a couple of SQL statements in order to get some customer information. Specifically, I'm using this one to get a count of orders where customer ID is that customer ID right there. I execute the command and save that within the order count property of the viewBag object. And then do the same thing to get the company name and concatenating this in the string there. Okay, so very dangerous kind of code. There's really a couple things that I'm doing here that are not good. One is I'm using dynamic SQL, which is always should be the last resort of how you do data access. And I'm also not doing any kind of user validation, user input validation. I'm not doing anything to make sure that customer ID is anything but a customer ID. Okay, so you can probably guess if you've seen anything about SQL injection that you can do a lot of different kinds of injection attacks with this sort of thing. You can do various kinds of ORs and so that it's concatenate in here in order to execute different kinds of logic in order to screw up the count that's returned or the company name that's returned. And there's a lot of very creative things that you can do in order to probe this action method in order to get additional information out of the Northwind database. But I'm going to leave behind all that namby-pamby kind of stuff. And let's go directly to some real damage. Okay, in this case, I'm going to click on this link right here. Take a moment. And as you see, we get an exception. Now I'm running this within Visual Studio, and so I get the exception right here. And you can customize that within the tools in Visual Studio. But the problem here is that I'm getting this exception. A transport level error has occurred when receiving results from the server. So that's kind of a weird exception. We can view the detail, drill down in here, and look at errors and inner exception. No process is on the other end of the pipe. Okay, that doesn't sound good. All right, so what has happened here is I can look at the customer ID that I passed in from the link. Notice that I'm providing the ALF key customer ID, so that's going to properly execute this statement right there. And then I'm closing down that customer ID with an apostrophe and then a semicolon and then executing the shutdown method. So what this has done is this has shut down my instance of SQL Server. Oh joy. So if I come over here and go into all programs and down here to SQL Server 2012 and configuration tools and configuration manager, that'll fire up. And if I go here to SQL Server Services, you can see that, in fact, my default instance of SQL Server on this machine is stopped. Okay, definitely not good that somebody can munge a URL and shut down my SQL server. Okay, so as long as I'm here, I'm going to start that back up. And we're good to go again. But you can just imagine how disruptive that sort of thing would be. And if I, once again, run the application just to show you this link, so you can see down in the lower left that I've just created an evil link where customer ID equals alpha key, and then put in a single quote, and then semicolon, and shut down, and so forth. So that second SQL statement that I tried to execute couldn't execute because, in fact, there was no SQL server at the other end of the connection anymore. Okay, so in a real production application, after you've deployed this code, you'd get the yellow screen of death, that horrible screen that indicates that something went wrong with an ASP.NET application. But I was running this locally, and so I was able to trap the exception within Visual Studio. Or you can do any kind of custom error handling. But overall, this is not a good thing. And also, the situation would have been even worse if I had executed shutdown with the no wait option. This option shuts down SQL Server without performing checkpoints in every database. So SQL Server exits after attempting to terminate all user processes. And then when the server restarts, a rollback operation occurs for uncompleted transactions. But it's likely that you have a cleanup mess on your hands, in addition to some very unhappy users. Okay, so it's a good thing to prevent SQL injection in your sites, beyond what MVC can do for you, which is pretty minimal. Because at this point, one of the problems with SQL injection is that it's very difficult to include protections within SQL Server itself, because it's getting a command that it thinks is legit. Maybe you have an application where you can remotely shut down the server, and there could be some legitimate reasons for that, some sort of administration application. So by the time SQL Server gets the command, it just looks at it as a regular command. So what can you do in your application in order to prevent SQL injection? And there are a few things that you can do within SQL Server to minimize the impact of it. Okay, here's where I start sounding like a broken record. Don't trust user input. That attack I just showed you worked because I did absolutely nothing to make sure that a customer ID was in fact a 5-character customer ID. So I trusted user input and I got burned for it. Okay, so there's a lot of things I could have done. I could have made sure that the customer ID consisted of just 5 letters because the table column is an nchar5. So it can't be anything more than that. If I accept anything beyond that, I am opening the door to SQL injection. So the tacit required assumption is that any data entering the system is malicious. It might be from query string parameters, form fields, request headers, or even file metadata like the EXIF tags in JPEG images that let you store pretty much whatever you want within the image itself. So related to that is you always want to validate data against a whitelist. Okay? Now, I've poo-pooed whitelists before, but it is one of the ways that you can provide a level of protection. In order to validate the integrity of the input, you need to make sure that it matches the pattern that you expect. Blacklists don't work because the list of potentially malicious input is huge and because it changes as attackers come up with clever new exploit techniques. So validating all input against whitelist is both far more secure and much easier to implement. In the case of Northwind customers, we only expect a string of 5 letters, and anything outside that pattern should have been immediate cause for concern. Fortunately, that's a very simple pattern that can easily be validated against using a regular expression. Simple data types like strings and integers are pretty easy, but the same principle applies to other data types. A registration form, for example, might expect a first name form field to be provided. The whitelist rule for this field might specify that it contain only the letters A to Z and common punctuation characters. But be careful with punctuation. There are numerous characters outside this range that commonly appear within names. Plus, it has to be within, say, 30 characters of length. The more constraints that you can place around the whitelist without resulting in false positives, the better and more secure you're going to be. Another big protection against SQL injection is to use parameterized stored procedures. Dynamic SQL from a client application is just plain evil. It has security issues and make it almost impossible to tune the performance of an instance of SQL Server. On top of that, executing them requires some pretty broad permissions, more than are really necessary for typical data access. There are a couple of native defenses built into using stored procedures. First, you have to define the data types of parameters. And if you pass the wrong kind of data, SQL Server will raise a conversion error when you pass the value. Second, the context of what this procedure, and by extension the invoking page, can do is strictly defined and secured directly to the named user. In the past, applications often needed to have broad reader and writer privileges in order to execute dynamic SQL, and those are no longer needed when you're using a stored procedure. And don't try to circumvent stored procedures by using them to build and execute dynamic SQL within the procedure itself. If you do that, you'll be right back to where you started with the SQL injection vulnerability. Now, as an alternative, at the very least, use parameterized queries. One of the problems with the code that I showed you is that the SQL string is constructed in its entirety in the .NET layer, and the SQL end has no concept of what the parameters are. It was all concatenated together into a single string. As far as SQL Server is concerned, it's just received a perfectly valid command, even though it may in fact have already been injected with malicious code. That happened on the client application. Using named SQL parameters gives you far greater predictability about the structure of the query and allowable values of parameters. If you use code like this, the SQL statement is a constant with the customer ID declared as a parameter and added programmatically to the command object. Then you can use the command object's parameters collection to assign the parameter's value, and that keeps the command channel separate from the data channel. And that's a key concept with most injection attacks, and certainly with SQL injection. Now, user executing this code still needs to have permissions on the customers table, in this case select permissions, but at least the parameter values aren't going to be considered executable code. Another option is to use LINQ to SQL for entities, any of the different flavors. Using an ORM, or an object relational mapping tool, is a good structured way to execute dynamic SQL from a client, but still have protections against SQL injection. Yes, LINQ generally generates dynamic SQL, unless you do the extra work of wiring it up to use stored procedures. The benefit of LINQ is both that it generally strongly types parameter values, so you get that kind of protection. So, for example, you don't accidentally allow a user to pass a long string where an integer is expected. Now, an important point about this is that techniques like using stored procedures, parameterized queries, and LINQ help prevent SQL injection. But you still have to validate input. Remember, clever attackers are always coming up with new and interesting ways to attack your site, and the more defense and depth you use, the better off you'll be. Now, the one thing that you can really do within SQL Server, as opposed to the client application, is to use least privilege. The reason why my shutdown command worked within that application is that I'm running the website as a machine administrator logged into SQL Server as a system administrator. So I have complete control over the machine, the application, and SQL Server. Shutdown is a very high privileged command. Shutdown permissions are assigned to members of the sysadmin and server admin fixed server roles, and they're not transferable. Had I been connected as a mere user, or even just a database admin, the command would have failed. This is just one small example of how least privilege can make your application more secure. If every user and process has only the permissions necessary to do their specific allowed tasks, the damage can be severely limited. There may still be some damage, but it'll be very limited. An attacker getting control of your app that only has select permissions on a single table in the database might get access to some information he or she shouldn't have. But at least that's all they can do. They can't drop databases, stop servers, gain control of the machine, or other even more nasty stuff. All too often, an application uses a single SQL account to perform all its database activities. This is a problem because that one account has to have all the permissions it needs to perform all the functions of the application, which likely means that the ability to read and write to a number of tables in one or more databases, even if the current user will only read from one of them. All that said, though, we have to be practical. If you do a thorough analysis of how your application would be used by a variety of users, you might end up with one or a few dozen SQL logins just to serve a single application. That's going to be a maintenance nightmare in the database. And even implementing the infrastructure in the application to support it is going to ratchet up complexity quite a bit. Another issue is that if you get too granular with logins, your application won't be able to make the best use of connection pooling, which requires that the connection strings be absolutely identical. Varying the login information with each just won't work. The bottom line, though, is that you have to balance security with other practical realities of application development.